So we are happy to share with you the modeling of malaria routine surveillance data to inform SMC strategy in Moyssala, south of Chad. So to start with, what is SMC? SMC, seasonal malaria chemoprevention, aims to prevent malaria in children under 5 in areas of during the high transmission season and consists of monthly administration of sulfadoxine, pyrimethamine, and amodiaquine during the rainy season. It has proven to be effective in reducing malaria morbidity and mortality, and it is recommended since 2012 by the WHO in countries with high transmission, highly seasonal malaria. Since 2022, it's also recommended in countries with longer transmission season with strategies tailored to the country's needs. So in Chad, malaria is the leading cause of morbidity and mortality, with more than 890 cases treated in under 5 in 2024. In Moyssala, south Chad, the incidence of malaria during the high transmission season is very high, with 40,000 cases in under 5 treated in average every year, from June to December. So now you can see on the slide a timeline with the evolution of the program in Moyssala and the weekly number of cases and the timing of the different rounds of SMC. So MSF program started in 2010, and the SMC started in 2012 and was progressively scaled up to the entire district with 4 rounds. In 2019, SMC stopped because it was not considered as an eligible area due to the long rainy season, but it was reauthorized in 2020. And in 2021, to take into account the longer rainy season, the Malaria National Control Program of Chad asked the addition of a 5th round to better cover the long transmission season. So this additional round was first implemented in November, and in 2023, the round was moved to June to cover the beginning of the rainy season. So here we are going to focus in 2018-2023 because we had access to a consistent data set from MSF. So as we have seen over the years, the number of rounds, 4 to 5, and the timing, starting months, have been implemented. They changed it. So we will call this the timing round, and the round the strategies. In addition, the number of cases are influenced by the timing, but also by the magnitude of the rain. But of course, the beginning of the SMC has to be decided ahead of the rainy season for obvious logistical reasons. So the objective of the model here is to inform what is the optimal strategy for SMC in Moyssala, and we defined optimal in terms of case averted using the routine data from 2018 to 2023.
Using only the data we have available, it may be difficult to determine the optimal SMC strategy. But by combining the data we do have with a mechanistic model of malaria transmission, we can answer more complex questions than if we were to rely on data alone. The mechanistic model represents malaria transmission dynamics with a set of mathematical equations. With our particular model, we account for many factors that influence malaria transmission dynamics, including incomplete reporting, SMC coverage, and a changing population. We also include real-time rainfall and temperature data, which influence the mosquito life cycle and therefore malaria transmission. Once we have our model, we calibrate it to the available data. In this case, our data is the number of weekly uncomplicated cases of malaria and those under 5 years old. Calibrating the model to data allows us to best represent the dynamics in our particular context. Now that we have our calibrated model, we can use it to assess different SMC strategies. These strategies could include, for example, 4 rounds or 5 rounds of SMC, or starting SMC in June or July. Shown here is the actual data, the observed number of weekly uncomplicated malaria cases, and here's the result of the model calibration process. The orange curve are the values given by the model, with the surrounding band representing the uncertainty interval. We see that our model is able to reasonably reproduce the malaria transmission dynamics in Moyssala. Now that we have some confidence our model is working well, we can use it to answer questions about different strategies. For example, what if there was SMC in 2019? What if a fifth round of SMC was not added until 2021? Or what if SMC in 2023 started in July and not June? We first explore malaria and Moyasala would have looked like in 2019 if SMC had not been stopped. The orange curve shows the strategy that was actually implemented, where there was no SMC in 2019. The shaded rectangles are the period where SMC was given. Now in blue is the alternative strategy where SMC was actually given in 2019. By comparing these two curves, we can quantify the impact of having stopped SMC in 2019. To better see the difference between the curves, we will zoom in on just the year of interest. Now comparing these curves, we estimate that about 11,200 cases would have been averted had SMC been given in 2019, translating to about a 19% reduction in cases during the high transmission season. This suggests that SMC is effective at preventing uncomplicated malaria and Moyasala. Now we try to quantify the impact of having added a fifth round of SMC in 2021 and 2022. Again, here in orange is the trajectory using the strategy that was implemented. So here that means doing 5 rounds of SMC starting in July in 2021 and 2022. And we add to this what had been done previously, which was 4 rounds of SMC starting in July. To measure the impact, we compare the difference between the two curves. Again, we zoom in to better see the difference. For illustrative purposes, we just showed 2021, but the results are similar for 2022. Comparing these strategies, we estimate that there were about 2,660 less cases per year, doing 5 rounds compared with 4 rounds would have been done. This is about a further 6% reduction in cases and suggests adding a fifth round of SMC had an impact on reducing uncomplicated malaria. We now try to determine the impact of having moved the 5 rounds of SMC forward so that the first round begins in June instead of July. We take a similar approach here and compare the strategy that was actually implemented, where in 2023 SMC began in June, to what was done previously, where SMC started in July, shown here in blue. Like done previously, we take a closer look at the year of interest. Here we have the number of malaria cases in 2023 on top, and rainfall in the plot below. We see that by putting the first round of SMC in June instead of July, the peak in cases at the start of the rainy season is prevented. On the other hand, starting in July and finishing in November prevents the small rebound that occurs towards the end of the rainy season. Looking at the difference between the strategies yields an estimated 580 less cases when starting in June instead of July, which is about a further 1% reduction in cases during the high transmission season. Although the difference in cases between strategies is small, the results suggest that starting in June helps reduce the peak in cases at the beginning of the season, which may help to not overwhelm the health system. We have shown that having added a fifth round of SMC in 2021 and moving SMC to start in June in 2023 likely had positive impacts on reducing the malaria burden. But the optimal strategy may differ year to year based on rainfall and temperature patterns. Now we try to determine what would have been the optimal strategy over the entire time period from 2018 to 2023 to account for these potential differences. We assess the 3 strategies actually implemented, so 4 rounds of SMC starting in July and 5 rounds of SMC starting in June or July. We also test one additional strategy of 4 rounds of SMC, with the first round being in June. Each strategy will be compared to a baseline. Here the baseline is the original strategy of 4 rounds of SMC starting in July. And we are assuming an SMC coverage of 86% for each round, so we compare the strategies themselves and not differences in coverage. We start with the baseline strategy, again 4 rounds of SMC with the first round in July. On the left is the reduction in cases compared to this baseline, and the right is the weekly cases from 2018 to 2023 under the given strategy. We now compare this baseline to 4 rounds of SMC starting in June, where we see little difference over starting in July. However, adding a 5th round has a pronounced impact, and shifting the first round to June leads to a further reduction in cases. These results provide additional evidence that the current strategy being deployed in Moisala, 5 rounds of SMC starting in June, has the greatest impact on reducing uncomplicated malaria cases in those under 5 years old.
So the study shows that SMC has an important impact on the malaria burden in Moisala, but optimizing the strategy could even help reduce further the cases. So the mechanistic model is a powerful tool to test hypotheses and inform SMC strategies tailored to the context. Other hypotheses can also be tested, like changing the age of inclusion in SMC, changes in rains or climate changes, or also interval between rounds. But the recommendation could also evolve as the rainy season and climate change. However, some limitations have to be mentioned. The model is always a simplification of the reality, and in our case, for instance, it does not take into account the spatial heterogeneity of the district within Moisala. Secondly, model outputs are as good as the data used, and changes in case reporting or a certain uncertainty in coverage data can affect the model output. So there are some next steps planned. So we are going to integrate new data into the model, such as severe cases and death, sub-district level data in Moisala, and previous years and more recent years. And finally, the model will be extended to include the RT21 vaccine that will be rolled out for the first time in June 2025 with SMC, and that should help to define the best strategy. Thank you. So finally, we want to thank our colleagues at MSF in Jamena, Paris, and Moisala, and the PNLP team, and also Swiss TPH and Epicentre, especially Clara and Anton. Thank you.